Hello, pre-calc 11s. It's time to start a unit. So we are finished with parabolas here, and we're moving on to trigonometry. This is a great unit. It's definitely got a lot of interesting stuff. I think for some of you, you might find it a little tricky, but for the most part, it should be pretty easy. We're going to quickly review grade 10 trig because we're going to be expanding upon this. So, CAH TOA. We have this lovely little mnemonic here. Can you believe how many bad puns you've gotten already? We have this mnemonic here, just a little refresher of what it means. Sine of an angle, so theta, remember theta is this guy, that's the Greek letter, that's theta. It doesn't have to be theta, it can be x or something else, but we usually use theta for angles. So sine theta is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So what this means is, if you know any two of the three sides of a triangle, you can figure out the angle, or if you know an angle in one of the sides, you can figure out another side. And these are just the three possible combinations. So someone came up with sine, cosine, and tan. There are three more, which are the flips, the reciprocals, where you've got like not cosine, but it's actually cosecant, if you're interested in flipping these around. But that is not really part of this curriculum. That's part of grade 12, so we're not even going to touch that, but just in case you're curious, there are three reciprocals. Anyway, okay, so moving on. So SOH CAH TOA, what that means here is if you've got a triangle, and the labeling scheme for triangles is generally something like this. A, B, C. Capital letters go on the vertices, smaller letters go on the sides opposite to them. So if A is all the way up here, all the way opposite from that, I'm going to call this little a. B is over here, all the way opposite from that is little b, and then little c is over here. Sometimes different letters will be used, sometimes we won't even worry about this, but the way that we can think about this in terms of opposites and adjacents, of course, is if we're talking about angle A, everything is relative. Now C is always the hypotenuse, because in this case, the hypotenuse is directly across from your right angle. But when I'm talking about angle A, the adjacent side is the one right next to it. That's what the word adjacent means. This is the adjacent side. C is the hypotenuse. And then the opposite side to A is this guy. And of course, if you change from not talking about angle A, but you want to switch up your perspective and talking about angle B, well, we can do that where we can say, let's look at this from the point of view of B, where this is the adjacent side to B, and this is the opposite side to B. So it just depends on what point of view you're talking about. So anyway, that's just a quick little refresher here. Now, if we want to solve some problems with trigonometry, because it's used to solve all sorts of problems, there's three general types of questions we can be looking at. And I've laid them out here for you. So we can solve for one of the three missing pieces, an angle, a side, or a different side. So the first example I'd like to do is let's solve for x if sine of 30 degrees is equal to x over 7. The proper steps in doing this is actually really simple. You set up the equation, sine of 30 degrees is x over 7. Then you multiply both sides by 7. Multiplying both sides by 7 cancels these out, and you've got x isolated. Using a calculator for this is generally needed, although sometimes for sine 30 especially, you might find that you know the value without a calculator, but generally we're going to have to use a calculator. So we're going to go to our calculator here. I'm using Desmos because it's available. 7 sine 30, you actually don't need to put a multiplying sign in there, and you can calculate it. One thing I'll just remind you of before you do anything, make sure your calculator's in the right mode. If you put it in radian mode, you get a weird answer. It has to be in degrees, and if you don't know what radians are, it's a different way of measuring angles that you'll encounter in pre-calculus 12, but for now we're all degrees. So what this tells us is x is equal to 3.5. All right, so we solve this and we get x is equal to 3.5. Life is good. Done. Another style is question 2, solving for side when it's the denominator. So what this makes you do is a little bit more work. There's a bit of a shortcut, but before we do the shortcut, I'm just going to show you the proper way of doing this. If you have a variable in the bottom of a fraction, the way you get it out of there is you multiply both sides of the equation by the variable. That cancels it on the right side and puts on the left side. So the next line down is going to look like this. X times cosine of 30 equals 5. If you want to get x by itself, we're going to now divide both sides by cosine of 30. Those cancel out, and you're left with x equals 5 divided by cosine of 30. Again, we go to our calculator here, and if we want to work this one out, we're going to go 5 divided by cosine 30, and we get 5.77. And there we go. Okay, so x equals 5.77. Put a nice little box around it, feel good about ourselves. Okay, it's not a nice box, but it's a box. And then finally, for solving for an angle, the proper way of doing this is to go tan x equals 0.25. Now, we're probably told about the inverse tan button. What you would do, or what I would really recommend you do, you don't have to write this out every time, but you must understand the inverse tan button. If you do that, inverse tan, if you inverse tan, okay, let's try this again. If you do the inverse tan of tan, they cancel out. But if you do it to one side, you better do it to the other. So we're going to take inverse tan of both sides. These cross out, and that leaves you with x equals inverse tan of 0.25. Most of us don't write it out that way, and most of us aren't even taught to do it that way. You're just told when you've got to solve for an angle, use inverse tan. But keep in mind, what this inverse tan is this is the undoing function to tan. So this undoes tan. So inverse tan of tan cancels out, you're left with x, and then the other side gets the inverse tan. Anyway, so what we wind up having is you have this. Now, if you're using a calculator, you're going to have to probably push second function or shift. If you're using Desmos, you've actually got to go to the functions, and you've got to find inverse tan right there. So inverse tan of 0.25, and that gives you 14.03. Okay, I'm going to just say 14.04. I haven't given any rounding rules, and I don't really care about it. 14.04, and you got to put degrees up there. That's super, super, super important. So x equals this. Okay, so those are the three styles. Now there is a shortcut here I wanted to mention for number 2. You'll actually notice that when you've got this kind of situation where you've got this here and this here, these two actually wound up over here. They wound up trading places. The 5 never went anywhere, but the x and the cosine 30 did. And there's a little swappy thing you can do. So you can just quickly go straight to this if you want. It's not a trick, it's just realizing that the way you do your algebraic manipulation ends up with that, and you can switch them around. And that only works in this structure of an equation, but if it comes up, which it does quite a bit, you can always use that. And it's not just for trigonometry, it's for anything. If you wind up having something like 7 equals 14 over x, these can swap, and you can have x equals 14 over 7. Okay, so that always works. Just a little fun math hack for you. Okay, pop quiz. So this is what you should do right now, just to make sure that you're all hunky-dory with all this stuff. Pause the video and do these questions. They're all on the screen. Pause it and give them all a try. Once you've unpaused it, we can go through the answers. All right, so I'm going to assume that you spend a whole bunch of time thinking about this and you have all your answers now. So what we would do for this is a very straightforward question. Solve tan theta equals 3 over 4. The way we're going to do this is we're going to go tan theta equals 3 over 4. I'm going to take inverse tan of both sides. No, you don't have to write it down every time, but it's good to have that in your mind. So inverse tan of 3 over 4, and we're going to quickly use this same thing here, and we're going to make sure the brackets are all around. We get 36.86, so I'm going to say 36.87. Okay, so that means theta equals 36.87, and what we just got is degrees. So let's just take a second, just think about this. what this would be is this would be a triangle, so that the opposite is 3 and the adjacent is 4. The right angle would be here, and what I just solved is that angle. Does that look like it could be 36.87 degrees? That should be about right. Okay, this next question, I'm going to do the little switcheroo. So I'm going to go straight to x is equal to 13 over sine of 65, and that's going to give me, let's see, what's 13 divided by sine of 65? 13 divided by sine 65, and I get 14.34. This here, 14.34, that is the side length. So if I was to sketch a triangle that kind of looked like this was 65 degrees. Sine is opposite over hypotenuse. So is it reasonable that x could be 14.34? Yeah. In fact, the hypotenuse is always the longest side, so it's got to be longer than 13. Okay, last question here, in 1 anyway. So we're solving for this. We can go straight to inverse cos of 1.2. And if we do this, we'll have to go to functions here, and we'll go inverse cos 1.2. It says undefined. Okay, that's interesting. Why the heck is this undefined? The reason is very simple. This number here, this means a ratio. And what this means is this is the ratio of, so 1.2 is equal to the ratio of adjacent over hypotenuse because it's cosine. So this is kind of like saying that the adjacent is bigger than the hypotenuse. That's not possible. The biggest value cosine can ever be is 1, where the adjacent and the hypotenuse are the same size. But to be honest, most of the time, the adjacent is shorter than the hypotenuse. So the ratio of them should be less than 1. Usually, cosine of theta is less than 1. Anyway, that's why we're getting undefined. Okay? It could come out as math error for you, or it could come out as something else, but it's undefined. It's not possible. There's no triangle where the adjacent is bigger than the hypotenuse. Okay, question 2. Here's a different style. If tan theta is equal to 3 over 5, then what's sine theta? So what some people will do is they'll try and solve for theta, and they'll go inverse tan, and then they'll work out sine of that. But I'm going to show you a better way of doing it. This is the second question, what is theta? So I'm just going to work it out real quick. But that's not really the best way of doing the question. What we would really like is we'd really like to go, let's just type in this here. Okay, so 30.96. So 30.96 is the angle, but if I don't want to go through this step, or the question's not asking me, how can I do it? Keep in mind that if we have a triangle that is tan theta equals 3 over 5, then what is sine theta? So what does a tan theta angle look like approximately? Okay, that's not going to be right. We need the opposite over the hypotenuse. So the opposite is going to be 3. I said hypotenuse, I meant adjacent. The opposite would be 3, and the adjacent would be 5. So if this would be theta. That's what the triangle would look like. If you're looking for sine theta, well, sine of theta equals opposite over hypotenuse. So if I know the angle, I can work this out, but I can also say, well, the opposite I know is 3, and I just need to know what the heck is the hypotenuse. Now, is there anything we know in math that allows us to figure this out? Yep, Pythagoras. So what we can do is we can write this as, remember, Pythagoras is a squared plus b squared equals c squared. So this would wind up being the square root of 9 plus 25, which would be 34. So we can express that as 3 over root 34. Okay, question 3. ABC is a right triangle where C is 90 degrees, and it's known that side C is twice as long as side A. So we're not told anything here other than here we've got maybe a situation like this. Here's my right angle, here is my little side C, and here's a little A here. So then I guess the other side would have to be B. So if I'm looking for determining cos of capital B is over here. Capital A would be up there. So if I want cosine of b, well, cosine of b is equal to adjacent over hypotenuse. So here's my adjacent side, and here's my hypotenuse. But I know that side C is twice as long as side A, so what I can do is I can write in C is 2A, and then the A's cancel, so it's 1 over 2. So what I can then say is that cosine of B is 1 over 2. Now, what a lot of people are going to do naturally is they're going to now go, okay, well then B equals inverse cosine of a half. But remember, I'm asking what cos B is, not what B is. This is cos B. That's the answer. Cosine of B is a ratio of sides. Lots of people get this confused and they think it's the angle. No. Part B, that's the angle. So B, I would go that step further that a lot of people do, just kind of automatically, and then I would inverse cos of a half. So if I actually do this here, maybe I can cheat, just erase that, right, inverse cos, and then I can go here of a half, and then it tells me it's equal to 60. All right, so 60 degrees. You always have to understand that the degrees is there. You have to put it in yourself. The calculators won't do that for you. Okay, question 4. This seems like an interesting question because this seems like it has nothing to do with trigonometry, but I promise you it absolutely does. So when graphed, what angle does the line y equals 3x minus 1 make with the x-axis? Okay, we'll kind of sketch that. We would sort of do this kind of thing. The slope, okay, well, we'll pretend that doesn't bend so much. The slope is equal to 3. So m equals 3, which means that if you move over 1 unit, you go up 3, so 1 over 3. So if I want to know the angle right in there that it makes with the x-axis, I know this isn't up against the x-axis, but it's the same kind of thing. It doesn't really matter here. What I can do is I can say that theta equals, well, what kind of ratio are we talking about here? We have what appears to be an opposite side, and we have what appears to be an adjacent side. So we should be able to write tan theta equals opposite over adjacent. And theta, tan theta, is equal to 3 over 1. So theta is equal to inverse tan of 3 over 1, or just 3. So when we go back here, and we enter this all in, we go inverse tan of 3, and we get an angle of 71.57 degrees. So what's kind of interesting about this is you'll notice that there's quite a relationship between tan and slope. If you want to figure out anything having to do with slope, it's related to the tangent function, because the rise-run triangle, right, if we have a line, here's the run, here's the rise, well, that's actually the exact same thing as saying, that's a terrible triangle. That's the same thing as saying we've got an opposite over an adjacent. And for some people who are knowledgeable about these things, they might also have heard of a tangent line. If you have a curvy graph, like let's say your graph maybe does this sort of thing and it curves, and you want to find the slope at one specific point, you would pick a point and you would draw a straight line there, and you call this a tangent line. It's actually called a tangent line because of the fact that it's related to the tangent ratio, where you've got rise-run, which is opposite over adjacent. So just a fun little bit of wordplay for you there. Okay, there's your review for trig. See you later.